Hello, I'm Nick Austin.
My name is Jonathan Sanchez.
I'm Kent Norman.
And I'm Bradley Livingston, and our project for 320 is to build a portable woodchip bioreactor. Basically, what we're trying to do with our project is to take wastewater and remove the harmful nitrates and turn it into nitrogen gas.
Yeah, so we're at the Cal Poly Air right now. This is an example of what it would be used for our design. 2 wastewater ponds, and in theory, our project would pretty much clean out the water and make it recyclable again.
The reason we want to do this is that we want to remove all those nitrates from the water. That way we don't have to worry about deep percolation or runoff and contamination. That way.
Okay, so I'm gonna start talking about a little bit how the denitrification process works. So essentially we're gonna have 4 tanks, a raw effluent tank, an aerobic tank, an anaerobic tank, and a treated tank. So the effluent's gonna come into the raw tank, be transferred to the aerobic tank, where a micro bubbler is gonna be pushing bubbles through all the water. And in that tank, it's gonna go, the shit water is gonna go through a nitrification process. And essentially what happens during nitrification is ammonium, NH4+, and oxygen combine and are modified by bacteria to create nitrates, H+ atoms, and water. So once that process has been completed, all of the effluents can be transferred from the aerobic tank to the anaerobic tank, which is going to have wood chips in it. So the reason why this tank has wood chips in it is because the aerobic tank uses a lot of the carbon source in the effluent, so we have to replace that with the wood chips. And in this tank, we're going to go through denitrification, which is where the nitrate produced in the nitrification process is reduced down to nitrogen gas N2. And then once that's done, it'll be transferred to a treated tank. And at the end, we're hoping for 10 parts per million of nitrate maximum.
Hey Brad, what you doing back there, Brad? I tell you what, Brad, this was our design that we picked. So it's a 14-foot trailer by 7 feet wide. We chose to go with an electric generator at the front, and we have 3 250-gallon tanks. First one is raw waste, then aeration, and then the third tank is you go to the wood chip tank, and then the last tank is for storage. So at the front, electric generator, and then on each tank, we're going to have pretty much just a support for each tank, because these are about 7 feet tall with 30 inches in diameter, which is like 2.5 feet. And then the wood chip tank right here, this is going to sit on the side, so closest to you, and all these tanks are going to be behind it. Our wood chip tank is going to be 9 feet in length and 3 feet wide, and the volume of that's going to be twice the amount of the other tank, so 500 gallons. And what we did is that we kind of put it on a slope to where it can easily be drained at the end. This is 22 inches and 16 inches. And at the top, we have a vent cap to let all the gases escape. And then each compartment right here will open, so it'll be really easy to service and clean after each use. Hey Brad, you paying attention back there or what? So this is the top view of our design. Again, it's just the electric generator at the front. And tank 1, tank 2, tank 3 is the wood chip, and then tank 4. This is the pump that's pretty much going to transfer everything from one tank to the other tank, so it's very movable and easy use. And it's all 2-inch, so it's really user-friendly and it's very simple.
Okay, so I'm going to talk a little bit about how to construct the different components for the system. So first we're going to talk about the anaerobic tank. So there's 2 parts to building the tank. There's the base and then there's the tank itself. Right now I'm going to just talk about building the tank. The first step in making the tank is going to be cutting out all the sheet metal that will be welded together to form the tank. That can be done with a plasma cutter. So basically what we're going to need is 2 sheets that are 9 foot by 3 foot. This is all going to be 0.04 inch aluminum sheet metal. For the ends, we're going to need 1 3 by 3 sheet with a 8-inch hole cut in the center at the bottom. For the other end, we'll need 2.5 foot by 3 foot piece. Okay, and then we move over here, and now we're going to do the bottom pieces and the top pieces to the tank. The bottom piece is just going to be a 9 foot by 3 foot piece of sheet metal. The top is going to have 2 or 4 pieces to it. So the top half will be a 9 foot by 1.5 foot piece. In the center, a 4-inch by 4-inch square will need to be cut because an air vent will need to be installed there. The other 3 pieces are going to be designed so that they can be opened easily to access the tank for cleaning. So 3 of these pieces are going to need to be cut. It's going to be 1.5 feet by 3 feet. And like I said, there's going to be 3 of those. We'll also need 3 hinges per piece, so a total of 9 hinges. Once you have all of the pieces cut for the tank, then we're actually going to weld all the pieces together using the drawings that are presented in the report. Once all those pieces are welded together, we're gonna have to fill the tank with soapy water. That stuff stinks. We're gonna have to fill the tank with soapy water and test it for leaks. If there's any leaks or any soap is coming out of the any of the welds, any of those welds will need to be repaired. And then the final step is going to be to install the valve that we're going to use here to clean the tank out and the air vent at the top of the tank, and installing all of the hinges. All right, so now we're going to talk a little bit about building the base for the anaerobic tank. So basically it's consisted of 5 supports that are all constructed from 1.5 inch tubing. Basically the tank is slanted, so each one progressively gets smaller. The width is going to stay constant, so each of these is going to be 36 inches wide. And the tallest one is going to be 22 inches. The next one down is going to be 21.5. Next one down is 19, 17.5, and 16. So basically the way that's going to work is you're going to have to first cut out all of the pieces. So for example, this one you need to cut out 2 pieces of the 22 inch for each side and 2 pieces of the 36 inch for each side, and then cut these middle support ones. Basically, once you get all of your pieces cut for these support members, you would weld all of them together just like this. And then to bolt each of these down to the trailer deck, we're going to have 2 of these plates per support member. It'll go 1 on this side, 1 on this side. So there's going to be a total of 10. Those dimensions are 6 inches by 15 inches, and these little support gussets are going to be cut out, and they're going to be 6 inches by 6 inches. There's going to need 20 of those for each. Yeah. Okay, so now to secure the vertical tanks, the circular vertical tanks to the trailer, we're gonna have to build some support brackets. So to do that, there's going to be these different parts that we have to weld together. So the first part up here is going to be the metal band that wraps around the tank and holds it to the support members. So to build that, we're gonna need these strips of metal, and they're gonna be cut to a total length of 98.2 inches by 3 inches. At the end of each strip, They're going to have to be bent at 90 degrees. Those will be 2 inches in on each side where the dotted line is here, and 2 holes will be drilled at 1/2 inch for bolts to go through. The rest of this will have to be rolled for a 30-inch diameter tank. And then basically what happens is that will be wrapped around the tank like this, and 2 bolts will go at the ends and tighten together to form a tight seal around the tank. From there, we're going to have to weld 4 36-inch by 1.5 inch tubing to the metal band, and then at the bottom of each support member there's going to be a bracket that needs to be welded so that it can be bolted down to the trailer. And the dimension for those are going to be 4 by 6 with 2 holes at 1/2 inch for the bolts to go through. We're going to need 12 of these for the 3 tanks. We're going to need 3 of the bands for the 3 tanks, and we're going to need 12 total mounting brackets for the tanks.
I'll be presenting the materials and cost list. So first off, we have this 250-gallon tank. We'll have 3 of these. Next up, we have our sheet metal aluminum. We're gonna have about 30 sheets of these, and they're all gonna be about 12 by 24 inches. And then we'll also have 6 sheets that are 9 feet by 3 feet that will be used for our wood chip tank. Next up, we have our square tubing. It's the length here is 1.5 inches, and we're gonna have about 36 of them, which are each 36 feet long. And then in order to be able to transfer all the fluids from each tank, we have this banjo valve that's gonna be on 3 of the tanks. Next up, we have our slide gate here from Fresno Casting. This gate here will allow us to open up to allow all the junk and all the wood chips to flow out to make the cleaning of the wood chip tank a lot easier. That's about $42. Good price. Here we have these hinges. These hinges are the ones that Brad was mentioning earlier that are used to allow the wood chip tank to open up. That way we could pour the wood chips in there and then close it for safety reasons. We have this air vent here that Brad talked about also earlier, and that's going to allow all the gases and everything else that's cooking in there to be released. We have this pump here. This is the pump that's going to be used to transfer liquids from tank to tank, not from the pond to the tank. So we have 2 pumps, and this is one of them, 1/2 horsepower. This is the flexible pipe that's going to be used with with the pump that I just mentioned before to move fluids from tank to tank. 2-inch pipe here. This is the generator that we're going to be used. We could either have it bolted or not bolted. We probably won't have it. That way you could just move it around, and in case you want to add some other stuff to the trailer. This is enough to run both of the pumps at the same time. And then this is our sump pump. Sump pump is the one that goes into the pond, and that's what's used to lift up lift up all the material that we need to. This has a total lift of 25 feet. Shout out to Dr. Howes for teaching us that. And then this is pretty much our cost estimate. Here we have our part number, the items, cost per unit, number of units, and the total. As you can see, our total price is about $2,855 with 89 cents, which is a little bit over our budget, but it should be fine. This is quality stuff. No quality stuff.
I tell you what, Brad, this was the first.
Video real quick. Say something, Nick.
Jonathan?
What? $40 for a parking ticket. I already paid $500 something to these park here. It's just like
That's going in the video.
Yeah. I'm Nick Austin. Go!
Okay, start over.
Okay.
You have to cut that out now.
I'm Nick Austin. Hello.
Hello.
Hello, I'm Nick Austin.
My name is Jonathan Sanchez.
I'm Kent Norman.
And I'm Bradley Livingston, and our project for 320 is building a Woodchip bioreactor bowl.
Bowl.
I meant to say portable. I'm Bradley Livingston, and our project for 320 is to build a portable bioreactor.
Portable wood chip bioreactor.
This is a portable Woodchip bioreactor.
And I'm Bradley Livingston, and our project for 320 is to build a portable bioreactor.
For wood
forgot to
chips.
say wood chip
Portable wood chip
bioreactor.
bioreactor.
Okay, someone has to take it.
Portable.
Portable wood chip bioreactor. I
There
get
we
it.
go.
God, okay.
Bradley Livingston, and now I'm getting sprayed with water.
Oh, Brad.
Do it one more time. I'm getting sprayed with water right now, so I'm trying to like look
Brad,
at
why
Okay,
are you
ready?
so high maintenance?
You have glasses on. I can't even see when I have water in my
Okay, but
eyes.
okay. Continue.
Wait, why am I
Hey,
the only one with sunglasses?
Go!
Dude!
No one has extra.
Hello, I'm Nick Austin.
My name is Jonathan Sanchez.
I'm Kent Norman.
And I'm Bradley Livingston, and our project for 320 is to build a portable wood chip bioreactor.